For more problems and videos like this for data structures, you can go to Sarai Studies. Link is in the description box below.
In the last video, we went over what a linked list was, and now we're going to talk about stack and queues. I'm going to show you what they mean, and then I'm going to show you how to code them using a linked list implementation, and then in the next video, we'll do stack and queues but using arrays. So a stack, what is a stack? Well, pretend that this is a table, and let's say that I'm going to stack up some books. So I stack on this book, and then I'm going to stack another one, and then I'm going to stack another one, and then I'm going to stack up another one. And notice that every time I'm adding to the stack, I'm only adding to the top. I'm not adding to the bottom, I'm not adding in between, I'm adding to the top. Because the way that you should think about it is that instead of a table, it's more like you're adding a stack of books inside a jar. And when you're adding a book into the stack, you can only do it from the top. There's no way that you can get it in between here. There's no space. And when you're removing from a stack, you have to remove from the top, because there's no way you can remove this one without removing the one from the top first. So the property of stacks is that the last book that was stacked, or the last book that came in, is the first one to go out. So the last book that came in is the first one to go out. So we add and remove from the same side, from the top. Now the reason that I spent 10 minutes on this video is to get a good foundation on linked lists, is because you can grab the code for a linked list, bring it down here, and this is a stack. All you have to do is change the name to, let's say, stack linked list, and then change the method names from add first and delete first to push and to pop. That's all we changed. A stack literally is a linked list, because in a linked list, remember, it was just linking a bunch of boxes. Those boxes were called nodes, and every time we wanted to add a new node, we had to do it from the front. And every time we wanted to delete a node, we had to do it from the front. So same thing, every time we want to add a book, we have to do it from the front, from the top. Every time we want to remove a book, we have to do it from the top, from the same side. So a stack works exactly the same as what we went over in linked list with this example. So if you haven't watched that video, make sure you do. Now let's look at a queue. So think of a queue as your grocery store line. This is checkout, this is a cash register, and let's say there's no one in queue right now, no one in line. But then we have this person, pretend these are people, and this person goes and is added to the queue, is added to the line, and then another person goes and it's added to the line. Notice that I'm adding from the back of the line. This person doesn't go and get added to the line from the front, because that would be cutting, it wouldn't be fair. They get added from the back. And if I want to remove a person, then the person in front of the line is going to go to the checkout. So once they check out, they're done, they're removed. I don't go and say, oh, this is the person who's going to check out. No, because they're last in line. That's not fair. So this is where you understand that queue is first in, first out. Whoever gets on the line first is the first to leave the grocery store, because they check out first. In other words, first come, first serve. Another way to remember it is, you see queen. I like to think of the queen as being served. So first come, first served, first in, first out, same thing. So unlike a stack where you could only add in from the top or from the front and remove from the front, from the top, here in the queue, you add in from the back and you remove from the front. Think of the grocery line. Now it also has a few other properties. It labels the first person in line, or the first item, as first, and the last one in line, or the last item, as last. So if I remove this person, then this becomes first and last. And then if I remove both of them, so one at a time, this one, then this becomes first and last. And if I remove this one, then they're both just pointing to null. So there's a few things to take into consideration, and I feel like it would be easier to visualize if we go back to our nodes that we are used to. So remember, this is the front of the line, the front of the queue. We're going to say we want something like A and B and C and have that point to null. In the queue, this is my first item, and then here, this is my last item. The goal is, let's write a piece of code that's going to get us to this. So we're going to say public static class queue linked list, because it's a queue, and we also want it to be public because we want it to be publicly accessible to anybody who wants to use this data structure. Because it's a linked list, remember that a linked list is just a link of nodes. Nodes are these boxes right here, so we actually have to use the node class that we created, because the node isn't built into Java. So we're going to go to our linked list code, and we're just going to go ahead and take this class and bring it down here. And something I did forget to mention in the last video is that this here is actually supposed to be inside the linked list code, so probably right about in here. So make sure it's inside your actual data structures. Notice that we have two variables to keep track of, the first and the last. And here's a fact when it comes to queues, they both start off pointing to null. So right now, our queued linked list literally looks like this. We just have a variable first and it's equal to null. We just have a variable last and it's equal to null. That's it. And they're of node data types. Then from there, we want to add our methods. We want to be able to add into the queue and also remove from the queue. So let's start with adding. So just like Stack has push and pop, queue has its own names, enqueue and dequeue. So to add, we're going to enqueue. So we have public void enqueue. This is the name of the method. We want to return nothing because we just wanted to add a node, so it shouldn't return anything. And it's public because we want people to be able to access this method. And we want people, when accessing this method and calling on it, to actually add the item that they want us to enqueue and the data type of it, which is string. So how do we actually want to enqueue an item? How do we add an item? Well, we discussed in a grocery line, we add it from the back. Let's say for a moment that this is what we had in a queue and we created a node that we wanted to add and it's somewhere in memory. If we want to add it to the queue, we want to make it the last one, right? So we have last pointing to it, but then the problem is we need this one to actually be pointing to this one, but we have nothing referring to it anymore, which is why before we move anything or do anything, we create a variable of data type node called old last that's going to refer to the current last. So let's do this again. Let's pretend that this is what we have in our queue. When we want to enqueue, let's say C, item C here, then we're going to create a variable called old last, and it's going to point to what last is pointing to, which is this node right here. And then we can go ahead and have last point to the new node that we created. So last is going to now point to the new node that we created. This node does not have a C, it's just an empty node. So we want to access that last nodes, which is this one's item, and set it equal to the item that the user wants, which is C. And then finally, have last dot whatever it's pointing to, have that be null because this will be the last item added in the queue, so there's going to be nothing that it should be pointing to. And then the last thing is to have this one connect to this one. So because we have a variable that's referring to this one, we can easily say old last dot next should point to this one. So old last is this node right here. Dot next means we're accessing its next and we're saying, hey, you should point to whatever last is referring to. Last is referring to this node right here, so this is going to end up pointing to this node. In other words, now we just linked the old last node to the new last node. And now we have a linked list. We managed to add this one in. But what if the list was empty? So let's go back to what we truly have at the beginning of a queue linked list, which is just two variables, first and last, pointing to nothing because there's nothing in the queue, nobody in the grocery line, right? And let's say that I want to enqueue my first node A. What we just said is take our variable old last, have that point to whatever last is pointing to, which is null. So we're having this point to null. Then we're going to create a new node. So if we want to enqueue A, here this is A, we're going to create a new node. So it's created here somewhere in space. And now we're going to have last refer to this new node that we created. So we're going to have last point to this new node. So last now points to this new node that we created. And so we're going to take last dot item, which is this right here, and we're going to set it equal to the item, which in this case is A. And then finally, we're going to take last dot next. So whatever last is referring to, which is this node's dot next, and we're going to have that point to null. And then finally, I read this, old last dot next is equal to last. Well, then old last is pointing to null. And this does not have a dot next because it's just null. So I can't connect it to this. But the thing you have to take into account is that this is the only node in my queue. So not only is the last recently added one, but it's also the first one. So we have to put in a condition here that if the queue is empty, then first should simply be equal to last. So there's nothing before this node. It's just going to be connected to null because there's nothing after it either. And we want to define that it's both the first and the last. So just like here, if there's only one person in line in the queue, they're both the first and the last person. And they make up the line, they make up the queue. So our condition here is going to be if, we're going to have a method called isEmpty and we'll write it. It's just going to tell us if the queue is empty and we'll talk about what that means. So if it's empty, then I'm just going to simply set my first equal to last. I'm simply going to have my first variable that's referring to null right now refer to whatever last is referring to, which is this node. So what's going to happen? This is going to refer to whatever last is referring to, which is this node. Else, which is what we experienced over here when it's not empty, we can just have the old last, which in this case is b dot next connect to the new node that was added in the queue, which is last. So we're going to move this over here. Now, of course, we actually have to write the isEmpty method. So I'm going to bring everything down. So my method is going to be called isEmpty. It's going to return a Boolean, true or false, like if the queue is empty or not. And it's going to be public because I want it to be publicly accessible so other people can use it. So what makes a queue empty? If you think of the grocery line, a queue is empty when there's no one in the line, meaning that first here is equal to null, to nothing, and that's it. First is the same as null. That is when our queue is empty. So now, after we create our node, we have it set equal to last, we have it point to null, we set the item and everything. Then we check if it's empty. If it's empty, then that means that this is the last and the first, so we just set first to refer to this node as well. If not, if there's things before it, then we take the old last, which is pointing to that actual node. In this case, old last is pointing to the actual node, and take that node's next and have it point to the one node that we just added, which in this case over here is C. So now let's actually go through a few runs to get it looking like this. So let's say I want to enqueue B now because I wanted to get it to look like that. Then enqueue B, what does that do? It sets my old last variable to refer to whatever my last is referring to right now. Well, my old last, I'm going to take it and I'm going to have it point to whatever last is pointing to. It's pointing to this node right here. I'm going to have it there. So this is done. Then I'm going to have to create a new node. So remember, when we construct a new node, it's just constructing a node with an item and a next, a pointer, and everything's empty. Then we want last to refer to that new node. So now last is going to refer to this new node right here. So this is done. Then last.item, so this is going to be equal to the item. In this case, it's B, because when we did enqueue B, now this is going to be set equal to B. That's done. Then we're going to have it point to null. So its next is now going to point to null. And then after we create everything, we have to actually add it to our queue. So because it's not empty, there's actually an old last one. There's a person already on the grocery line, if you want to use that analogy. Then it's going to take the old last. In this case, old last is referring to this node right here. It's going to take its next and have it point to whatever last is pointing to, which is this new node right here. So in other words, this goes away, this goes away, and now instead of pointing to null, it's going to point to whatever last is pointing to. Last is pointing to this node, so therefore this is now going to point to this node. And now we have it looking how we want it. Let's do one more. So let's say we want to enqueue C. We want to have it like this. What does it tell us? Take old last, have it refer to whatever last is referring to now. Last is pointing to this node, so we have to have old last also pointing to this node. Great, that's done. Then we're going to create a new node. So it's just an empty node, because that's what we have. Empty item and the next a pointer. And we're going to have last refer to this node that we just created. So we're going to take this and have it point to this node. This node right now is empty, so we have to take this last. Last is referring to this node now. Its item, which is over here, have it equal to the item, which in this case is C. So that's going to be C. And finally, we're going to take last dot next. So last is this dot next is this. Have that equal to null. And if the list is empty, which is not, this is not going to end up being the first item because it's not, it's this one. Then we're going to take whatever the old last is, we're going to take its next. So this is old last, its next is this, and we're going to have it point from null, there's supposed to be a null there, to whatever last is pointing to. So last is pointing to this node. So that means that this here needs to point to this node as well. So it's no longer pointing to null, but instead it's pointing to this new node here. And now we have it just how we want it. Beautiful, our enqueue works perfectly. But what if we want to remove, to dequeue from the queue? Well, then that's another method. So this is what we have so far. So let's say that we want to dequeue. Remember that we can only ever remove the first node from our queue. Just like in the grocery line, we can only ever remove the first one in. It's FIFO. So first one in line is the first one to go out. So we can't like remove this one or this one. It's always the first one. So we have our method called dequeue. It's going to return a string because we want to confirm what we just removed. And it's going to be public because we want it to be publicly accessible. So what do we want to happen when we dequeue? Well, we know that this one's going to be removed, but it's not necessarily going to be deleted. Another way to think about this is no longer going to be the first node in our queue. Instead, it's going to be this one, because if we remove this one, then this one here becomes our first node. So this here is going to become our first node. So in other words, we're going to have first now refer to whatever this node was pointing to. So at the beginning, this node was first, and then whatever it was pointing to was dot next. So we're doing first dot next. So again, this was first. This node here is what it was referring to, and then dot next was referring to this B node. So in other words, first is now going to refer to B. And because nothing is pointing to this one anymore, it's no longer part of our queue. So it still exists somewhere in memory, but it's literally now part of our queue, so we've technically removed it. But here's the problem. We want to be able to return the string. So before we even did that, we had to create a variable called item data type string and set it equal to the first node's item, so that when we change what first was referring to, in other words, removing the first node, we could return what we removed, like so. Now you want to consider the situation when you're dequeuing and your queue is empty after you make the first refer to whatever the old node was referring to. So in other words, let's just pretend that this is all we had. This was the only node in our queue, and so not only is it the first, but it's also the last, and it's pointing to null. Now if we want to dequeue and this is all we had, then it's going to remove this node. So in other words, it's going to hold the item, so it's going to hold A, it's going to return A, but before that it's going to have first, this here, point to whatever first, which is this, at the moment, next was pointing to, which is null. So it's going to have first point to null. And so now this is ideally removed, but we still have last pointing to it. So remember what first pointing to null means. It means that the queue is empty. So in other words, after we remove this one, the queue is empty because we have first pointing to nothing. So there's no one in the grocery line. There's no one in the grocery line. First is pointing to null, meaning no one's on the line, no one's on the queue. So last pointing to a node that's no longer there doesn't really make sense. So in other words, we have to add a condition that checks if the queue is empty after setting first equal to whatever's next, which in this case, it is true, first is equal to null, so it is empty. Then what do we want to do? We also want last to no longer be pointing to the last node, but to whatever first is pointing to, which is null. So we want last to refer to whatever first is referring to. So they're both, at the end of the day, going to refer to null. And so this is somewhere in memory, it's by its lonesome, nothing is pointing to it. And so therefore we're left with our queue right here, which is what we started with, an empty queue. So that's the recipe, the algorithm for a queue. And I hope you found this video helpful. I'll see you in the next.